Okay. Hello, everyone. My name is Michael Garry. I'm shecco's editor-in-chief of the Accelerate Special Issues and online news sites. I want to mention that the new issue of Accelerate Special Issue on food retail best practices is now available at accelerate24.news. It includes two articles on two of the presentations we'll be hearing today on Longos and Hannaford. So I encourage everybody to read those. I want to welcome everyone to this commercial end users and contractors session at Atmosphere America 2020. I'm happy you could join us online today. We have an excellent session in store for you. First, a reminder that as an attendee, you can ask questions at the right of your screen under live discussion, and I encourage people to do that. We'll answer questions, as many as we can, at the end of the session. I also encourage you to answer the polling question, which is available also at the right of your screen, and we'll see what the results are at the end. All of these presentations at this session and the other sessions will be available online for 1 year after the conference if you wish to refer back to them. So we have a great panel assembled for today, for today's commercial end user and contractor discussion. Our first speakers, well, first let me mention who they are. All the speakers we have from Longo's, Dave Mastroieni, and from Neelands Group, Vyas, who will be speaking first, followed by Harrison Horning with Hannaford Supermarkets, who will be speaking second, and then third speaker, AJ Milbes from Calwest Refrigeration. So our first speakers, let me just introduce them a little bit. Dave Mastroieni, if I have pronounced that correctly, is Vice President, Procurement and Facilities at Longo's.
Dave Mastroieni, Michael.
Say that again?
Dave Mastroieni.
Yeah, that's good.
Okay. Is Vice President of Central Procurement and Facility Management with Longo's, which is a Canadian chain serving the Toronto area. Dave has over 35 years of leadership roles at Longo's, including operations, distribution, supply chain, and has been instrumental in the rapid growth of the company over the last 35 years. The other speaker on this one is Vyas, who's Vice President of Energy and Digital Services at the Neelands Group. And Adi has led the energy and digital services at Neelands Group. It focuses on creating value for the customer by reducing their energy consumption, on high energy, high efficiency equipment selection, on-site generation, and bringing pieces together with a digital layer for remote monitoring, control, and optimization. And he led the design and construction management for the near net zero grocery store in Stouffville, Ontario, Canada, which we're going to be talking about today. So without further ado, I'll turn it over to Adi and Dave.
Well, thank you, Michael, for the kind introduction. And this presentation is a joint presentation between Dave and I. I cannot thank Longo's enough on behalf of Neelands for having this valuable partnership that we have for about 30 plus years. And not just as a business partner, but Dave also happens to be a good friend of mine, and we are almost neighbors now. So there's a lot of history here between the two companies. Is it time for me to share the presentation? Let me see if I can get that going. Can you guys see my screen okay?
Yes, yes.
Okay, very good. So first of all, thank you, Shecco, for giving us the opportunity to speak about a sustainable supermarket. Today, Dave and we're going to talk about one of the many Longo's stores. And, Dave is going to talk a little bit more about Longo's in a little while. But, Longo's is one of the leading supermarket chains, privately owned. But, the unique thing about Longo's is they like to push the envelope further. And we are very fortunate that we have kind of grown with Longo's, and we're part of this supermarket that was developed in Stouffville, Ontario. So a little bit about Neelands Group. We are Neelands Group is a family owned business founded in 1958. So about 60 years that we have been in existence. And we started off primarily as a refrigeration company, but as of today, we do the full complement of refrigeration, HVAC, control systems, equipment sales, energy management, optimization and monitoring software, 24/7 service. We are not a manufacturer. We are an EPC contractor, right? So from engineering to procurement to construction, and then service afterwards. So we like to take pride in being a turnkey provider for services, and have been for the last 6 decades or so. So just to kind of quickly talk about the areas, and there's more areas than this, but if you think about what Neelands does, there's kind of 5 key areas. One is refrigeration, which is kind of our bread and butter and how we started our company. But we also do a full service HVAC and service of the equipment. And then of course we are we try to be as green as we can, and moving towards sustainability, not only ourselves but also our customers and partners. So I want to take a moment and let Dave talk about Longo's.
Great, thank you. So we're family-owned business, similar to or the same as Neelands, and it was started out by 3 brothers, 1956, Tommy, Joe, and Gus Longo. And today we're into our 2nd and 3rd generation of family that are involved in the different areas of the business. We have 37 locations, retail locations currently. We also have an online shopping facility that we shop on in a different site. We self-distribute, and we have our own distribution center. We have approximately 6,000 team members, and we're still growing, slow pace, but we're still growing with a few sites planned in the near future. So our relationship with Neelands started about, well over 30 years ago, predominantly for refrigeration services. But as similar as Adi mentioned before, it evolved into equipment supplier, into store design, and now into sustainability solutions. So the full gamut of offerings is what we do with Neelands today. What this slide shows here is just a shot of the 3 generations of family, some of the family members, and really the whole theme about this slide is and the premise of our business is just doing the things the right way and the fair way, and that's kind of how the family has grown the business. Relationships are very critical in our business with vendor partners, team members, and ultimately guests as well. Okay, Adi.
Thank you, Dave. And Dave's pretty modest. I have to add, Dave joined Longo's when I think there was only 1 or maybe 2 stores, and has been is very instrumental in this phenomenal growth of Longo's stores. So I'm people here in a joke, Adi, you like to talk, and I'm like, yes, I do like to talk, but more than that, I like to talk sustainable. I like to paint stories, right? And this kind of goes back maybe in 2016, Dave, or something, when we first started talking about what could the future store look like? And we said, well, and this was a blank canvas, really. Dave, myself, and a few others, Tom from Neelands. We all started shooting ideas, for lack of a better words, throwing spaghetti to see what sticks. I said, well, a store of the future should really use less energy than a traditional store. We can't say we're making a climate impact unless we're reducing GHGs. And then we talk about resiliency centers, as grid becomes more and more susceptible to outages and to other attacks. What can we do to make these giant 40,000 square feet space into resiliency centers? And that's kind of how the whole discussion started around the sustainable store. In the picture here, you see the finished product actually. So this is the store at Stouffville. You can see it carries the same look and feel of a Longo store, and has a beautiful solar panel layout. We'll talk a little bit more about that in the next slides. But let me first start off by the approach, right? So what was the approach to make this happen? You'd often hear me say, in God we trust. Everybody else bring data. I'm sure Michael is probably smiling right now because I used that quote earlier with him. We started off by collecting data. I think data is so much critical, and we have one more panel later on about digitalization, and we'll talk more about data collection. And then we see, well, let's analyze, like, where's the energy being consumed? Where can we save? Where are the low-lying fruit? And then you start developing the project. And as you develop the project, you always think, well, we need to be able to tap into some incentives. We need to be able to see what's available out there, because at the end of the day, everybody wants to have a business that makes money, do the right thing, but make money. And so we started off by energy mapping. And if you see, I'm just going to keep moving this around so we can focus on where things need to be. But if you look at a traditional 40,000 square feet store, you would see they use about little over 2 million kilowatt hours a year, and most of that goes into refrigeration. I mean, this is pretty typical of any store. And then there's a gas usage of about a 10,000 meter cube per month, and most of that is for space heating and for kitchen, right? Not just space heating, this should say, and kitchen, because there's a lot of cooking that happens in the grocery stores. And we said, well, what can we do so we can make a holistic approach where we have some kind of generation, but we are utilizing all the heat from the generation, in all months of the year. So yes, we are from Canada, but it's not frozen 12 months in a year. We do have some nice summer, about 3 months or so, and we do have some warmer weather too. So we need to think about what can we do to have that impact all year long. We started with the design charrette. We got some experts into the room. We start saying, well, okay, if you start off, and EUI is energy use intensity, right? So that's a way to normalize how much energy a typical building uses. So if you think about grocery stores, they have some of the highest EUI in all commercial buildings, right? It's the only thing that tops grocery stores are hospitals and super malls, right? In terms of how much energy they use. And so he said, well, can we, what can we do? Can we share a wall, right? So instead of an independent store, can we have like a store next to it so that at least one wall is shared? Can we do an improved vestibule? And started going like deep dive into every single one to see, how we can make an impact. So the Neelands differentiation. So we start off with a holistic approach. We said we don't want to have a single generation source. We want to tie the generation, refrigeration, heat reclaim, everything into one. And I'll talk a bit more about the storage integration and CHP, base loading and stuff like that. I just heard a beep, which means I need to probably rush a little bit. So I want to make sure I get to the meat and potatoes of this project. So if you take a look at this is not a block diagram. This is an actual schematic, just simplified. where you see that this is the generator that we have, which is about 150 kilowatt generator. It has, it produces electricity, but then the heat from the exhaust and from the engine go into this, go into this in the winter times. In the summer times, we go into the absorption chiller, so from where we get cool out of it. So even though we have 3 or 4 months, we still need to make sure we are utilizing the heat. And I'll talk about this in just 1 second. But in the summer months, what do we do with the heat? So in the summer months, sorry, in the winter months, we just take the heat. And then it goes into this heat exchanger, and then onto the RTUs, right? So originally we thought we'll put it into all kinds of different RTUs, but ultimately there's a financial payback. So there are 3 specific areas where the heat is required the most in a grocery store, and all the excess heat kind of goes there. Of course, if there is need to be a heat dump, we'll have a heat dump, but we try to avoid that as much as we can. And in the summertime, you get the cool, and yes, you can use the cool to cool the store. But remember, grocery stores don't have, especially in this climate zone, don't have much of a cooling load. So we take the cool and we tie it into our CO2 system. So we have 2 racks here, rack A and rack B. And then, as you know, CO2 systems can go into transcritical mode, and hence by using more energy. And the thought process was, can we make this whole system as one where generation, heat reclaim, and refrigeration all act as one single unit at a higher efficiency? And this is where this project is different from most of the projects. So we talk about the result, but if you think from a customer perspective, when they walk in the store, they see this beautiful carport. When they walk inside, they don't see it any different than a regular store, because from a user interface, you want to make sure that this is as transparent as it can be to the end customers. And this is what they see. From a technical perspective, you see behind the building, there's a CCHP unit. You have the nice job that Neelands does with the CO2 rack, and the gas coolers on the rooftop. This is just a top-down view where you can see the panels and the CHP. What you see here is the battery, and if there's time, we'll talk about battery storage shortly. So we do have some online monitoring. This is just a snapshot of year to date. It's a work in progress, so some of the numbers don't reflect. Battery is not connected yet, but we are already trying to monitor that. But if you look at the numbers, for me, numbers make sense if you start comparing to a regular store. And if you look at a standard store, there's 2 basic operational costs. Consumption. Sorry, I'll let Dave speak about cost, but there's the electricity cost, and then there's the gas cost. If you look at Stouffville, we have CHP generation, we have solar, which shows minimal, and that's more regulatory. And if there's questions, we can address that. And then gas consumption. But if you look at overall, we started off with a goal of about 30%. We ended up about 25% better in terms of consumption comparison. But to most people, kilowatt hours don't mean anything. It's dollars. I'll let Dave talk about dollars here for a second.
Okay, so we've been at it now for a little over a year. So the first year, against our base model store that we did the whole project with, there's a difference of almost 140,000, about 138, and which the results were pretty good in with our expectations. Yeah, and the return on investment is would be about a 4 to 5 year if it stays at this pace, which this year we are overperforming at this point. So all in all, it from a numbers point of view, the first year was positive. We had a couple hiccups at the beginning, obviously getting the system up and running to be as efficient as it can be. And I know that the Neelands team is still fine tuning it. He meant Adi spoke about the battery storage that we're just in the middle of installing. It's already is installed. We just haven't commissioned it yet. So once we get that in, then we should expect to see better benefits for this upcoming year.
At the end of the day, everybody is interested in doing the right thing, but we want to make sure that there's operational savings. Thanks. And then, just to wrap it up, Longo's is a very important customer, to Neelands, both from a personal relationship perspective, but also our growth. We attribute a lot to Longo's, and we really appreciate them having us, do some demonstration projects with them. But apart from Longo's, there's a few other customers that we service in the greater North American region. Our headquarters are in Burlington, Ontario, but outside of that, we have one more office in Ontario, and a half office in Florida and in Georgia. There's one in Washington that's going to come in soon. So thank you for your time. Sorry if I went just a bit over, but thank you for listening.
Okay. Thank you, Adi. Thank you, Dave. That's really a fascinating project in Ontario that you have there. Quick question from me, and then we'll move on to the next presentation. I was just curious, you mentioned that the store looks pretty much like a normal store to the shopper, but has Longo's tried to communicate the environmental initiatives around this store to the shopper, so they know that Longo's is trying to do good things for the environment?
So I think Longo's has a very, very humble and approach to things, but I'll let Dave speak about it. They have sustainable events, and they have some boards and stuff. But Dave, why don't you address this?
Sure. We've communicated when we opened the store to the neighborhood and the community. We had a couple small open houses. Could we have done a better job? Yes, absolutely. So we're in the process of doing some setting up some guided tours for our guests, and also some of the vendor partners as well that we're involved and also that are interested in for other sites as well. So there is more work to come on that. If I had to do it again, which we are in the process of doing another one in the near future, I think we'd really be a little less humble and really kind of communicate to the community what we're doing and how that helps everyone. So
yeah,
we learned a lot from this one. Anyways.
Yeah, you should not be modest. It's definitely worth talking about. I think it's a great message, for Longo's to send out there. I'm sure a lot of people care about the environment who are your shoppers and would be impressed by what you've done. Okay, well, thanks again, Dave and Adi. We'll get back at the end with additional questions. But for now, I want to introduce Hannaford, Harrison from Hannaford. A little bit about him first. So Harrison is the Director of Maintenance for Retail Business Services, a subsidiary of Ahold Delhaize. His role is focused on supporting Hannaford Supermarkets, which is based in Maine, and Stop and Shop, which is based in Massachusetts, and also serves, that happens to be my local supermarket in Connecticut. Those two chains together have about 600 stores in 8 states in the Northeast. Harrison has had over 25 years of experience in this field of facilities and energy management. And he also holds the distinction of being on the very first issue of Accelerate America that Shecco ever published. And I will be forever indebted to him for that. And so with that, I'll turn it over to Harrison.
Okay, thank you, Michael. Let's see. Are you seeing my slides?
Not yet.
All right. Let me. I gotta do something different here. Hang on.
Franco?
There we go.
Oh.
Let's go to this one.
There you go.
Okay, sorry for that. All right. Well, are we good, Michael?
Yes, go ahead.
Okay.
You're good.
So hello, everyone. I want to talk about a project that Hannaford recently did in South Burlington, Vermont. And to start with, just kind of a little background, I've been working with Hannaford for 20 years. And about 10 years ago, we had the first Atmosphere America conference. And, the company was trying to address, greenhouse gas emissions and the use of natural refrigerants in particular. And we really, we rolled up our sleeves and started testing things. And really for the last 10 years, we've been testing things, and we've tried some things on new stores, such as this example in South Burlington, Vermont. But what we're really trying to get at is what can we do in existing stores where we have, there's hundreds or thousands of existing supermarkets in the US today. And we'd love to have solutions that can introduce natural refrigerant systems and or systems that significantly reduce greenhouse gas emissions. The Ahold Delhaize companies have recently announced an ambitious goal of reducing greenhouse gas emissions by 50% by the year 2030, based on a 2018 baseline. And that is a science-based target that is, predicted to have a meaningful impact on reducing the temperature increase globally. So we have some good reasons to pursue this. And some of the things that have been tried are, systems with smaller charges of HFC. And, one way that's been done is by using a water glycol loop on the high side to reduce the amount of charge. So instead of going to the roof to condense, you go to a plate heat exchanger right next to the rack to condense, and you can reduce the amount of refrigerant. We've also done several projects with transcritical CO₂ booster systems, which completely eliminate HFC refrigerants and give us a very low greenhouse gas impact from the refrigerant emissions. And those booster systems can do the low temp and the medium temp cases and walk-in coolers and freezers. Recently, we've dabbled with micro-distributed systems with R290 or propane on the low temp cases. In some cases, or in some stores, we've not even needed a rack, where those low temp cases each have a couple of condensing units on top, and they condense right in the condensing unit, and then the heat of rejection is picked up by a rooftop fluid cooler. So no refrigeration required at all outside of the condensing unit on those low temperature systems. So that's a very attractive opportunity that we've done on 3 stores recently, including this South Burlington store. And when we looked at that, we said, okay, this is easy to do on the low temperature cases, the frozen food cases, ice cream cases, where it's okay to have, a little bit of extra noise there on top. The condensing units are not that loud, but it's pretty easy to make it work where ambient noise is not a concern. We can hide the units a little bit. And but on the medium temp cases, we have a much bigger variety of low profile cases, service cases where you need to have conversation and noise is a bigger concern. So what could we do on the medium temp? And we had the option to go with CO₂, like even if it were not a booster system, but let's say you could have a CO2 transcritical medium temp only rack feeding CO2 to the cases, or we could have what we call secondary glycol. So what we thought of was, what if we did both? And that's like, you know, you could say, well, why bother with glycol? But we like the simplicity of glycol on the sales floor versus CO2. The controls are more straightforward. You don't need EEVs or electronic expansion valves. You don't have the asphyxiation risk, you know, which you typically address with monitors and alarms and so on. And so there were some reasons to be attracted to medium temp glycol. And we really liked the idea of how do you chill that glycol. If you can chill that glycol with a natural refrigerant, then you kind of get the best of both worlds. You know, the economics were, you know, challenging because you, at first blush, you're saying, well, now I need to purchase a CO2 chiller and the pumping system to pump the glycol, and so the cost is higher. And we were fortunate to receive an incentive from Efficiency Vermont to help, you know, to kind of offset the incremental cost of this test. The important thing here is we've been at this for 10 years and we're not done yet, particularly looking for solutions for existing stores. And I think the micro distributed cases, you could think about replacing, you know, existing cases with those. That's one effective way to address greenhouse gas emissions. And you can also replace medium temp cases with glycol cases. So it has potential for existing stores. A little bit about this store. It's a 60,000 gross square foot store. My apologies to the metric people in the audience, but you can do the math. Again, the low temp loads in this store, the doored cases are micro-distributed, water cooled. And then the walk-in freezers and the frozen coffin cases are water-cooled condensing units that are sitting above the walk-in boxes and piped locally to those evaporators. Well, the medium temp loads, the cases, and the walk-in coolers are all served by a chilled glycol system. And the glycol is chilled by an R744 chiller with an adiabatic gas cooler on the roof. We worked with Zero Zone and they were very cooperative with us in designing this chiller and you know, looking for what you know, how we could make it work in this particular project. I think you know, another thing about the well, let me back up on that slide. I think well, let's go on to back to the low temp system, the ambient fluid cooler on the roof. So this, again, low temp cases have condensing units on top of the case, and the heater rejection is taken away by a glycol loop to this fluid cooler on the roof. It's designed for, I believe, 115 degree Fahrenheit temperature. So it's able to handle high ambient temperatures, which in northern Vermont, you know, we typically don't get much. We typically don't get over 100, so we should have plenty of safety factor there. We always have the option to spray a garden hose on top on this fluid cooler if needed, but that was not required. And pretty much we were able to you know, get through the hot, humid summer with no issues at this store. So that's kind of a fascinating development, if you will, where again, this low temp system has, you know, the only refrigerant in this low temp system is a small amount of R290 in the cases, and then a relatively small amount of R448A in the condensing units that serve the walk-in freezers and the coffins. So that's kind of, I think I reported on that last year actually, and Now for the interesting part, the new part, I should say. This idea of using an R744 chiller or a CO2 chiller for medium temp loads, what we were really trying to look at is the idea of what can the marketplace offer today in the commercial refrigeration marketplace that could be used for this application. And you take the idea of a commercial chiller, commercial package chiller, and you could go out and buy commercial package chillers, buy 2 or 3 of them so you have redundancy, and use them for this application. But typically the maintenance is difficult. Sometimes they're small packages and they require, you know, a multi-day shutdown for service. And in this business, that's generally not, the service contractors don't like that, and it can be a problem for the operators of the store. So we tend to lean towards more of an industrial process chiller. And so we thought, well, what can the commercial refrigeration manufacturers offer today that looks like an industrial process chiller and that fits our needs? So you know, we worked with Zero Zone and came up with this unit that you see in the photo. And one thing we did was we made it fairly small in the width dimension, if you will, where we had to fit it into a small room and through a door and everything. So that was something that if we had to do over again, the maintenance guys would prefer to have a little more space. But that gets to the whole issue that we were exploring of, you know, what will this thing look like, and you know, what are the compromises we need to make between serviceability and fitting it in a space and so on. So we decided we wanted the evaporators on board with this skid, kind of to make it, you know, so the factory, all of the high pressure welding could be done at the factory, except for the gas cooler connections. And, you know, it would look a little bit more like a package chiller. In retrospect, the service guys are saying, hey, you know, you could have put the evaporators remote on little skids separate from the rack. Would have been a little easier to service the evaporators. But again, it's a trade-off that, you know, that we discovered. And this is really all about learning as we go. So this basically, the evaporators on board this unit chill the glycol, and then there's remote pumping stations that pump that glycol out to all the medium temp cases and walk-in coolers. Here's a quick shot of the adiabatic gas cooler, and this, you know, really allowed this system to stay subcritical throughout the entire summer. And it takes all of the medium temp heat of rejection. Again, this was subsidized by Efficiency Vermont, as it is certainly, there are certainly energy savings and cost savings by keeping that condensing temperature down, where you don't suffer the efficiency penalties in those high condensing conditions that you would get if you were going transcritical. So that was a good thing, and thank you again to Efficiency Vermont. And so what did we learn? Again, on the low temp, we learned that fluid cooler alone provides adequate heat rejection during the summer. So, you know, there's no refrigerant needed outside of the condensing units, which is a very small charge. The second thing we learned, adiabatic gas cooler maintains subcritical operation, and the benefits again were really saving money and saving energy. We learned more about what this would look like. It's a kind of an industrial system. It's not, you know, your plunk and dunk commercial package chiller, you know, multiplexed or whatever. I'm still intrigued by that. I'm still wondering if the market will move towards something more like that, but this is where we're at today. We need adequate space for installation and service. And there again is that trade-off between, you know, you want a big industrial unit that's easy to service, but somebody's going to tell you you only have so much space to fit it into. And along that line, we opted for onboard evaporators, which if we had more space and we had some field welding in addition to the gas cooler, we could have done them differently. So in conclusion, it was a learning experience, and I think we learned what we set out to learn, and we're mulling it over for what do we do next. And I'm very hopeful that we can discover some cost-effective things to do on existing stores, but I realize there are challenges. So thank you very much, and I'll give it back to let's see.
I can take it, Harrison. Thank you.
Okay, I'll go back to new share. What do I do? New share? Yeah.
You can just stop sharing your screen.
Oh, stop sharing. Oh, there it is.
Yeah.
Got it. Thanks.
Okay. Thank you very much, Harrison. That was very interesting. Just a quick question for me. You mentioned the opportunity in existing stores, which of course, as you point out, there are a lot of those out there that still use HFCs and so on, even R22. And I believe that you are planning to install some of these R290 cases in existing stores. What can you tell us about that?
Yeah, we've been looking for opportunities now for about a year, and to be quite frank, in this business, the opportunities ebb and flow. And there are other things going on in the business right now that have kind of gotten in the way of it. So I can't report we've had any action on that, but we are still looking for good opportunities, and I'll keep you posted.
Okay, great. We're looking forward to that. Okay, so at this point, our third speaker does not seem to be available. Is that correct, Franco?
No, he's there.
Oh,
Hi,
he is.
AJ. Yeah.
I'm sorry. I apologize. AJ is here.
Yes,
Okay.
I'm here. Can you hear me?
AJ, there you are. Good to see you.
Thank you.
Thanks for joining us. I'm very pleased to introduce our final speaker, AJ Milbes, who's Director of Operation for Calwest Refrigeration. And AJ is an experienced operations manager with a demonstrated history of working in the commercial HVAC and R industry. He's skilled in HVAC and commercial refrigeration installs, service, and programming. And most importantly, for the Atmosphere Conference, he's a firm believer in natural refrigerants. Is that correct?
I am.
All right.
I am.
Good.
But we
good,
lack
good.
in some areas. That's why I'm here today. Talk about training.
Yeah, and I wanted to say AJ was kind enough to jump in to this session. We had a late cancellation from another speaker, and we were very appreciative of your
Yeah, of course.
filling in at the last moment. So thank you for that, AJ, and I'll turn it over to you.
Okay, a little bit about Calwest. We're a full service provider. We do engineering, construction, and service. We currently operate in 4 states. Our biggest customer is the United States government, Uncle Sam. Currently in our portfolio, we have 2 micro DS stores, 3 Glycol and 4 CO₂, and I think we're adding another 4 CO₂ stores next year. I'm very limited on time, so I'll try to fit everything that I want to say in the brief time that I have. But, one thing that we are constantly running into is training on all these new systems. The industry already is very limited on employees. I'm seeing a big trend in people leaving and not coming in. And the older guys that are in the field, it's a lot of technology for them. We're pushing it pretty hard. I know some people think that it's moving slow, but it's not. CO₂ is definitely increasing very fast. And, one thing I'm noticing is just the lack of training or availability for training especially with COVID-19 now, I mean, training's almost been non-existent. And so, how do we expect to really push this technology and expect, our customers to jump on CO2 when we don't have enough qualified people? And there's two parts to that. You got the construction side, which we got to show them how to properly install these systems. And then you have the service side, how to properly service these systems. I could tell you this, one of the big differences I've noticed from a regular store, an HFC 404 versus the CO2 is the serviceability is a lot easier and there's a lot less problems. But there's still that factor of not everybody's trained on how to properly service it, and what do we need to do to maybe have a standard of training for CO2, because that's another big thing is you got guys going to tech schools or trade schools, but they're not even teaching this technology at tech schools. And so while it's all it's all great on the front end, everybody's pushing this technology, but on the back end, you guys are kind of neglecting, okay, maybe we should get these contractors more familiar, because I can guarantee you in the United States, I would say maybe a couple percentage points of contractors that are actually experienced and working on this stuff. Everybody else, they don't have the experience there. And we do reach out to Hill Phoenix, to Hussman, some of the other manufacturers. But like I said, there's just no standard that we see right now that is kind of a baseline of, okay, this is what we should be training our guys. You there, Mike?
Yes.
Okay. And, I'm a firm believer in CO2. But I also like the micro DS. The two stores that we do have that are micro DS, they're very easy to work on. And the feedback I'm getting from my guys is, they'd rather work on the micro DS or the glycol versus the CO2. What we do for our CO2 stores, though, to kind of protect us and back us up, is we do keep 2 or 3 extra chargers on site for those stores. We do keep a set of gauges, CO2 gauges on site in case, we have an emergency and the tech that we do send doesn't have CO2 gauges, because as you know, those are like $800-900. And if you were to give a pair to each tech out there, it's a large investment. I feel like the industry isn't really focusing on the training as much as they should be, because I know that if we were to get contractors trained and they all understand the system, they would sell more of it, but you can't sell something that you don't know. And that's pretty much, all I wanted to talk about. If anybody has any questions, I'll be happy to answer it.
Okay, AJ, thank you very much. That was very illuminating about training, ongoing challenge in the industry. I think there's been some progress made, but from what you're saying, we have a long ways to go.
Very long way.
One thing that jumped out at me was when you said that, compared to HFC or R404A, the serviceability of transcritical CO2 is actually easier. Did I get that right?
I did, and
Yeah.
we have a case study right now that we're doing. We still can't understand why, but we're not seeing some of the usual problems that we see with HFC stores. Some of the service calls that we get for our CO2 stores are either going to be, loss of charge because there was a power outage and it was just too hot, or an oil problem, but those are rare versus our HFC stores where you get clogged, TXVs or some of the other problems that you usually typically get. We're not seeing it in CO2. I mean, I could tell you because we have all these stores under contracts, and those stores with CO2 are most profitable, just because we don't get any calls from the stores. But we also do monthly maintenance on those stores, so I'm sure that has, a big role to play in it also.
Okay.
But yeah, we don't understand. They don't have problems.
Well, that's encouraging. Certainly, probably people are not even aware that that's the case. That if they knew that, then maybe they would be less intimidated by CO2, perhaps. Okay, we had a poll question. Franco, I don't see the results of the poll on my.
Yeah, I can read them out for you. No
Yeah,
problem.
if you could. Yeah, the
So
question is, I'll read the question. Which natural refrigerant system will be most widely used 5 years from now in food stores?
So there's been 53 people who have voted so far.
Yeah.
The top answer, 43%, was combination of transcritical CO2 and R290 cases. Second, 36% was transcritical CO2. In third place was R290 self-contained cases. And last at 6% was ammonia CO2.
And what percent for R290 self-contained?
15%.
15%. Okay, that's a really interesting, that's an interesting result. The combination, which is what Harrison's talking about of R290 and CO2, got the highest vote, 43%. And then transcritical next at 36, and self-contained R290 at 15. And then of course, ammonia is still very new to the game at 6%. But does that surprise you, Harrison, that this thing you're talking about, which I thought was a fairly unique combination, is, I guess people are impressed by what you said.
Well, I also think you could think of it in terms of some stores get the CO2 and some stores get the micro DS. You end up with a combination. You wouldn't
Okay.
necessarily have to say it's done in the same store.
Oh, I see. Yeah. I guess that was my, what I was trying to get across would be that they would be in the same. Yeah, that's true. But you can interpret it that way. That's true. Yeah. And of course, there are stores that have a transcritical CO2 central system. And then I think in your Hannaford does that too, with where you have some spot R290 merchandisers. And
Yeah, I think to me, it's kind of like how far can you go with micro DS? And when you get into those, the fancy low profile cases or service cases or coffins where you really don't have a place to put the condensing unit conveniently on a micro DS. So I think if you end up where Hannaford ended up was, hey, the micro DS works well here on the low temp frozen food cases. Let's figure out how to do the rest of the store. So you might get into it that way as well.
Right. Okay. All right. Now, here's a question from the audience, Peter D. AJ, how can manufacturers support contractors in training?
Well, I think, with COVID, I think a lot of people are limited to training. We can't have classroom training, but Emerson, they've over the years done a really great job with their training where they offer different schedules of, different topics at parts houses. And those are usually have big turnouts. And I would say just working with, supply houses to get in there and start offering these classes. A lot of techs, they love those classes. And I understand right now it's COVID, a lot got canceled, but maybe, next year, if this all goes away, we start pushing to get into these supply houses and having a set schedule, for the next year. Like, this is where we're going to be, and these are some of the topics that we're going to talk about. Because, not everybody can afford to fly out to Georgia to get training or, Tennessee or whatever. So working directly with the suppliers and, maybe spending a month at different parts houses in California and then Texas and then Arizona, and having a schedule, and you're kind of teaching the same thing, it'll at least give you, a standard of, what to teach, and everybody's getting taught the same thing.
Mhm.
But, right now, not many people are offering anything. And
Mhm.
so it's been literally a learning freeze since March. And
Right.
so everything just got put on hold. But yeah, if they could get into the supply houses and start offering some of these classes, a lot of people will get into it and will learn. Keep in mind, I mean, we're paying right now a much higher premium for newer techs just because there is no techs out there. So the guy that, we could have hired, say, 7 years ago, fresh out of school, was 14 an hour. Now it's costing us 30 an hour. So the cost per tech to train is coming at a way higher premium than previous years. And so that's something we also got to keep in mind. But yeah, I think supply houses are the way to go.
Do you do training at your facility?
We do controls at our facility. That's it.
Mhm.
Yeah, we do training on controls. We are looking into setting up a small CO2 rack to train our own guys on. But right now we're not. The only thing we offer in-house is full commissioning controls from A to Z.
Okay.
Michael, do you want me to read out some of the questions from the live discussion?
Yeah, no, I've got it.
Oh, okay, cool.
Yeah, Debbie Koski, from CTS. Are any of the ammonia schools, Garden City, Lanier Tech, NWTI, starting CO2 training courses? I don't know if these folks would know the answer to that question. I think the answer is yes. If I'm not mistaken, Garden City is doing that. And anybody know about CO2 training classes anywhere? Like Harrison,
So
how do
from
you
our perspective,
Yeah,
like,
go ahead.
we get our training from the manufacturers, right? And
Yeah.
then for our own staff, and, I agree with AJ, it's very hard to find techs, who know CO2. And there's also a little bit of hesitance from like the existing folks, right? To touch CO2 system, right? Because they know HFC and that's all they know. But from a training perspective, we rely on manufacturer, and then like our construction team, like when we start off a project, we have this layered approach on how we teach the apprentice from one to the next kind of level, and then train them kind of in house, right, as we do the installs and or service with experienced tech.
Okay. We'll take this one last question. We have time, running out of time. Eric Teal asks, has shecco engaged with RITA and RITA TI for support in training of technicians and operators? We at shecco, that I'm not aware of anything like that at shecco, but certainly something we could explore. And we'll keep that in mind. I'll pass it on to Mark and Ilana. And with that, there's another question. We'll get back to you after the conference. But I need to close this session. I want to thank our speakers from Longo's and Neelands and Hannaford, and AJ from Calwest. Thank you all for this excellent presentation today and updating us on these really cutting edge technologies. So I'll do the clapping since we're without an audience, a live audience, but I'm sure there's clapping going on out there somewhere. But thanks again, guys, and we really appreciate it. And I want to remind people that they can read more about the Longo's and Hannaford case studies discussed today in Accelerate special issue that's available at accelerate24.news. And with that, I will close the session. Thank you.
Thank you.
Thank you.
guys.
Bye.
Thank you, guys.
Great job. Thanks. And AJ, thanks again for filling in. Harrison,
No problem.
Addie, Dave, great job.
Thank you.
Thank you, guys. We'll be in
Thank
touch.
you.
And don't forget, you guys, if you haven't seen the issue, take a look. I hope you like the articles.
Thank you.